All right, 9.5 we were looking at last time, permutations and combinations, and we had one more example to take a look at. All right, here's our example. We've got a committee, and the committee is going to have 3 people selected at random. It's going to be selected from among seniors, juniors, and sophomores. And what we're looking at is the probability that the committee consists of all seniors. That's part A anyway. So the first thing to recognize is that you have to decide on all of these problems, just as a reminder to take you back into this section. Am I dealing with something where the order of the choosing matters? Okay? So does it matter when you have a committee if you were selected first to be on the committee or last to be on the committee? No. So this one is a committee, right? It doesn't make any difference whether or not you're first or last, which means this would be a combination. Combinations are when order doesn't matter. So we're dealing with combinations here. That's the first thing to remind ourselves. Now, what we're wanting to do is we're wanting to find the probability of something using combinations. Well, we want the probability the committee consists of all seniors. So how many committees are there of all seniors? Well, how many seniors are there? 7. How many people are on my committee? 3. So I can find the number of senior committees, that is committees of all seniors, by doing 7C3. There are 7 people, and I'm going to choose 3 of them. Okay? But that's not all the possible committees. That's just all the possible senior committees, right? Committees with only seniors. So what in the world is it to find, or how many different committees are there total that I could find? How would I find that? All right, yeah, we want to add all the possible people to pick from. So how many possible people are there? 15. There are 15 people possible, and any of the 3 of them can be selected. So what you want to remember, and this question actually ties in this section 9.5 back into 9.2 that I gave you back on your homeworks today, is that you're looking at the number of ways that you get what you want to have happen over the total number of ways that it's possible for something to have happen. So in this case, we want all committee members to be seniors, or at least that's what we're trying to figure out in the problem. So we have that 7C3 on top. And then all possibilities would be the 15C3 on the bottom. All right, so we're going to do these one at a time. I'm going to actually do them in steps. You can certainly do them from where we are, but I think that it might be a little bit cleaner to do them one at a time. So I'm going to do 7C3 down here. So remember combinations? Do you remember how they work? What goes on top? 7 what? Factorial, that's right. So the first number that's listed in front goes on top. What goes on the bottom of a combination? One of them is the 2 numbers subtracted, 7 minus 3 factorial. There's something else in the bottom of a combination. The 3 factorial. Now if this were a permutation, we wouldn't have the 3 factorial. That's the difference, okay? So what we're going to do then on top is, and let's recognize then that this is simply 4, right? So I'm going to write down 7, 6, 5, 4, and I tend to stop at the very first chance I can. Stop at the 4 factorial. And then I have 4 factorial on bottom, and then the 3 I can write as 3, 2, 1. Now remember, the only way that I can reduce inside of a factorial is if the factorials are identical. So like I can reduce 4 factorial and 4 factorial because they exactly match. But I couldn't sort of reduce like a 4 factorial and a 2 factorial in that way. You can't just cancel out the number and somehow reduce it like fractions. Yes?
What happened to the exclamation point?
I wrote the 3 factorial here. I wrote it as 3, 2, 1 because that's what factorial means. It means 3 times 2 times 1. So I just wrote it out. All right, so then the 4 factorials cancel. 7 times 6 times 5, if you want, you can multiply them all out. Or you can reduce them sort of piecewise and notice what's 3 times 2? 6. So this actually becomes the number what? 35. 7 times 5 is 35. So going back up to the actual problem, I found out that my numerator is 35. I want to do the 15C3 now. So let's do the 15C3. All right, so what goes in the numerator? 15 factorial. What goes in the denominator? 15 minus 3, which is 12 factorial. I'll just write it that way. And then what else? 3 factorial. Notice the two numbers that are in the bottom add up to the number on top, right? The 12 and the 3 add up to the 15. The 4 and the 3 add up to the 7. All right, so I can actually write this out till I get to 12. 15, 14, 13, 12 factorial. And I like that because that matches a 12 factorial I already have. All right, pretend that looks like 12 factorial, because the way the screen is, I have got something at the bottom of my screen I can't write on top of. And then I have the 3, 2, 1. So the 12 factorials, just like the 4 factorials before, cancel. 3 will reduce with the 15 if you want, right, to give me a 5. And the 2 will reduce with the 14 to give me a 7. So this is 5 times 7 times 13. What is that? How many? 455. So up here, this is 455. Now, that reduces because you know that at the very least, they both have a 5 in common because they both end with 5, right? So if I reduce them by dividing by 5, this gives me 7 over what? What's 455 divided by 5? 91. This actually reduces one more. Because the 91 divides by 7 to give me what? 1/13th, yeah. So this is 1/13th. Now if you happen to recognize it, you might have recognized that down here. Look, here was a 5, here was a 7, here was a 13. Do you see that? And this was the 5 and the 7. So those are whatever you're reducing. So this is actually reducing completely with the 5 and the 7 in the denominator. So we have 1 over 13. It doesn't matter where you recognize it, but at some point it will simplify to 1 over 13. So that's not real high percent chance, right? I mean, like 1 out of 13 is less than a 10% chance that all of them are going to be seniors. Agreed? Okay. All right, we have one more part of this problem. This one says, what's the probability that the committee has no seniors? Now, notice this is not saying that it doesn't have all seniors. Do you see the difference? Having not all seniors means that I could have some seniors, just not all of them being seniors. This says no seniors. So what does that mean if I have no seniors on the committee? I don't have those 7 to choose from, which means I have 8 that are left. I have the 8 underclassmen, juniors and freshmen, or junior and sophomores, right? So the problem actually becomes 8C3 over the 15C3. And I already did 15C3, so I know that's 455. So once I've done the problem once for that piece, there's no reason to redo that. But 8C3 is not a piece I've done, so let's do that one.
Where do you get the 8?
There are 5 juniors and 3 sophomores.
Okay.
Yes. I should have flipped back to that screen. All right, so 8C3. What's going to go on top? 8 factorial. What's going to go on bottom? 5 factorial, 3 factorial. All right, so this is 8, 7, 6, 5 factorial, which matches the 5 factorial, and then 3, 2, 1. All right, so there goes our 5 factorials right away. And then what's 3 times 2? 6, and that happens to be on top. So what's 8 times 7? 56. 56 over 455. I don't think that one reduces. Oh, no, it does, because they both have a 7 in them, yeah? They do. So what is it? I get an 8 on top. What is 455 divided by 7? 65. And since 8 is even, only reducible by 2s, and 65 is not, we're done. So it's an 8 out of 65 chance, which is higher than the other one. Still not dreadfully high, though, but it's higher than the other one.